is to bridge the gap between the science and market from his personal experience in patenting and licensing technological innovations. Professor Gagler is a distinguished professor emeritus at Rutgers, New Jersey, USA, and he's also an Albert Einstein Professor of the prestigious Chinese Academy of Sciences in China. He has an accomplished academic career spanning about 4 decades, and where he has published more than 300 publications, 8 patents, 9 technological issues, and 10 commercial products so far. He has been editor, co-editor, and member of the advisory board of multiple international journals. Professor Gagler is the recipient of more than 40 honors and awards, including Fellow of the American Society for Advancement of the Sciences, Fulbright Senior Scholar, medals, and Fellow of the Japanese Society for Promotion of Science, Entomological Society of America, Society of Nematologists, and many more. Professor Gagler has visited about 90 countries to lecture and attend conferences and to conduct and collaborate the scientific research. His research so far has received about 18,000 citations. Now, I would like to invite Professor Gagler to start today's talk, which is very much important for nowadays. Thank you very much.
Thank you.
Gagler, please.
Appreciate the opportunity. Assalamu alaikum. Let me begin by saying that if you think I can only offer an academic perspective, that know that I once took a 2-year leave of absence, and with a biotechnology company, and I've also served or chaired on the boards of several biotechnology companies. So how do we bridge this gap, the science and industry gap? How do we close this gap between the academic and industry worlds, between idea and product? You bridge that gap with patents. And it's important to understand what that gap is. That gap is largely a cultural gap, because the academic world and the industry world have radically different values, and those sort of misunderstandings can disrupt technology transfer. You have one culture that values studying problems, and the other values solving problems. One culture values openness, the other one thrives on secrecy. One favors moving carefully and slowly, while the other prizes speed. And one is fiercely independent and loathes the supervision and accountability, whereas the other one is the polar opposite. So if you want to be successful, you have to understand, respect, and appreciate the industry values. So why do you want to do a patent? You want to do a patent to protect your intellectual property for the next 20 years. That protection from the patent enables licensing technology to industry. Patents are a precondition to obtain a license and to commercialize your invention. That's what the endpoint is. The endpoint is not the patent. The endpoint is a license and commercialization, seeing your idea become real. Now, the first step in a patent is not having an idea. You can't patent an idea. The first step is to identify a need. In other words, a problem that needs a solution. Okay, here's a problem in need of a solution. The world's biggest killers aren't sharks or crocodiles or snakes or even humans. It's mosquitoes that transmit disease. Mosquitoes kill 750,000 people a year, mostly children. And Pakistan is quite familiar with mosquito-borne diseases, malaria, chikungunya, and especially dengue and many others. Now, the strategy to control these diseases has been to kill the mosquitoes with chemical insecticides. But now there's a British company, Oxitec, and they're offering a genetic means of mosquito birth control. This requires rearing massive numbers of transgenic male mosquitoes for release in the wild that then mate with wild females, resulting in most of the offspring dying. So Oxitec is field testing this cutting edge idea right now, this summer, in the Florida Keys. They're releasing 75 million genetically engineered male mosquitoes into the Florida Keys. Now, in order to do this test, they have to rear nearly 200 million mosquitoes. And that is a big, big mountain to climb. But if the Florida test is successful, to meet the US market alone, Oxitec would need to rear hundreds of billions of laboratory reared mosquitoes. Now, finally, we come to the need. You see, there's a bottleneck in rearing mosquitoes, and that bottleneck is blood. Female mosquitoes, as you must well know, require protein to make eggs, and they get that protein from blood. Now, blood for mass rearing mosquitoes comes from slaughterhouses, and it's offered usually in a blood bag type of a feeding system. Now, here's the problem. Blood's expensive. It's highly variable. It has a very short shelf life, and it has to be certified as pathogen-free. Moreover, these systems must mimic a vertebrate host. And that means that the blood has to be heated to a mammalian body temperature. There must be a membrane for the mosquito to pierce. There has to be a phagostimulant, usually ATP, to induce feeding. And all of this is cumbersome and it's expensive if you're rearing millions of mosquitoes. So there's a need, and that need is to develop a blood-free feeding system. In other words, an artificial system. An artificial system without blood, then you don't have to mimic a vertebrate host. And if you don't have to mimic a vertebrate host, you don't need heat, you don't need that membrane, you don't need ATP. And also, blood's got the shelf life of a jug of milk. So if you don't have blood, then you don't have any instability issues. So clearly we have identified a need. Now what you need is an idea that'll meet that need. So here's our idea. Our idea is to eliminate blood, and that centers on the duality of mosquito feeding. Yes, females, they require blood because that's where they get the protein to make eggs, but they also require sugar, and they require that sugar for energy. They usually get that from flower nectar or other plant sugars. So our diet, this R510 diet, is super simple. It's simply 5% sugar, and we use sucrose, and it's 10% protein, and we use serum albumin. So they're getting sugar and they're getting a protein. Sugar is a very, very strong phagostimulant, and it fools the mosquito into ingesting the protein concurrently because we're providing the BSA, the bovine serum albumin, together with the sugar. So that is, and here's the key, the mosquito is entering a plant nectar, not a blood feeding mode. And consequently, there's no need to mimic a host. Now, it's not just a diet, it's a feeding system. There are only 3 components. One of them, of course, is the media itself, the diet, a powdered diet of sucrose and bovine serum albumin. There's a dish to hold the diet. And then there's a plastic mesh. And this plastic mesh is important because it floats and the mosquitoes are using it as a feeding platform. So you just add water, you shake it, and you add mosquitoes. Now note the feeding platform floats. So as the fluid level drops, the mosquitoes can still access the diet. So here's the mosquito taking up her diet. She thinks she's getting sugar for energy, but at the same time, she's being fooled into taking a protein for eggs. So again, here, there's no need to mimic that vertebrate host. You don't need blood, you don't need a membrane, you don't need heat, you don't need adenosine triphosphate. So again, the central idea here is that we're exploiting the sugar feeding behavior of mosquitoes to fool them into taking a protein that they normally get from blood. Now, that's a great idea. but you can't patent an idea, as I've said. It's best to show that your idea actually works. And that means what I call proof of concept research. So for an artificial mosquito diet, these are the three criteria which must be met in order to have a viable media. Let's start with the first one. Females must readily feed and engorge. Well, we have plenty of photo and video evidence that shows it takes the females less than a minute to find and then engorge. You see the distended abdomen on this female. So it's not a problem, but we need actual data. So here we are comparing feeding on our artificial media versus blood from a live guinea pig. A live guinea pig, this is the gold standard, the optimal mosquito diet. Yet we get 9 out of 10 of the females are engorging on our artificial media, but with the live guinea pig, we're only getting 3 out of 4. So how did our system, our artificial system, perform better than the gold standard blood? Very simple. Because we can allow at least 24 hours for the mosquitoes to feed on our media. But federal regulations limit feeding on animals to about 1 hour. And you don't get much more time on a blood bag because when you start heating blood, it becomes unstable very quickly. So we're just allowing more time to feed. And if you get more time to feed, then you get more engorgement, so you get more protein uptake, and that results in better nutrition and healthy mosquitoes. So first criteria has been more than met. The second one is no loss in fecundity. It's not a useful diet if you get less eggs. And this really is the key criterion. If you're getting less eggs, it means you're providing suboptimal nutrition. But as this data shows, even after 10 generations on feeding on our system, our mosquitoes show no loss in egg production. That is no loss of fecundity. So we have met that criterion as well. Now, if there's no loss of fecundity, but if those eggs show fertility that's not good, that's a real problem. So fertility is the third metric that we look at. In our system, almost all of our eggs hatched, about 96%, even after 10 generations. So we have met all three criteria. We have demonstrated that our idea actually isn't just an idea, it's an idea that works. Now, here's the key for any patent. The patent examiner wants to know if your invention is novel and non-obvious. This is the most common reason for rejection. Well, in our case, we have demonstrated an unconventional blood-free feeding system with a new mechanism of protein uptake. This system works. We see no loss in engorgement. We see no loss of fecundity or fertility, even after 10 generations on that system. And it has massive advantages over the existing system because it's simple. And it's simple because there's no need to mimic a host. And moreover, it's very cheap relative to blood. And it's storage stable. The diet can be stored pretty much forever, whereas blood, as I said, is like a jug of milk. So now we have an idea, we validated it, and now we're ready to prepare the next step in the process, which is the disclosure document. The disclosure document is something I submit to the University Office of Technology Commercialization. They are the university's gatekeeper. It's their money, and they're not going to put up tens of thousands of dollars unless they have confidence that my invention can be patented and has some viability. So I want you to do what I do, is think of these people as investment bankers. That is, they need to make a return on their money. So the patent disclosure form itself is multiple pages. It usually takes me about 2 days to fill it all out. And they want to know everything. First of all, they want to know about prior disclosure. In other words, have you talked or written about your invention previously? Because if you have, that technology is dead on arrival as far as a patent is concerned. There could be no prior disclosure. They look very closely also at the relevant literature because it allows them to see if there's any related work that may make the idea obvious and not patentable. And lots and lots and lots and lots of other questions, like I say, page after page that has to be filled out in this disclosure document. So the university is now, I've submitted the disclosure document, and the university is now doing the first evaluation. They want to know two main things, and they will rely heavily on your disclosure document. First of all, is your idea patentable? That is it sufficiently new and sufficiently novel? Second of all, they want to know, is your idea marketable? That is the market that's targeted already too saturated with products, or is it too crowded, or in my case, usually is the market too small? Now, it can cost ₹1 million to secure an international patent and fees and lawyers. So the university is very cautious in their evaluation. Again, it's their money. Now, if the university evaluation is positive, the university will file a provisional patent application. Now, this is important. Provisional means temporary. It does provide you patent pending status, and it gives you first to file status, extremely important. But a provisional patent, this temporary patent application, is not evaluated by the patent office, and it is not published by the patent office. That's how we distinguish it from what I would call a real or regular patent, which is called a non-provisional patent. So the provisional patent is not evaluated and not published. But now you've got 12 months protection. That is, you've got a year before you file the non-provisional patent, the regular patent. You got 12 months, and the clock is ticking. This clock is ticking. 12 months goes fast. You have a lot to do. Yalla, yalla. Use that 12 months. Do more research to perfect the invention, to make the non-provisional patent application bulletproof. Begin to look for industry partners for support. This is when marketing really can begin, because you have protection now. You can talk to industry partners. You can build relationships. And because you're protected now, you can give talks and you can publish that work in a journal. And this is what I always do. I'm looking for 2 publications. I want to publish the patent and I want to publish the research in a journal. It's a twofer. Now, a couple of points on this provisional application. The first is the applicant. I am not the applicant. The owner of the technology isn't me. It isn't you. It's the university. But I am one of the inventors. Now, look, I recognize that honorary authorship is common in the Middle East. That's an ethical issue that I won't address here. But there are no honorary inventors. Inventor is a legal term, and this is a legal document. Inventor identifies those who contributed ideas. A patent can be thrown out if the list of inventors is challenged. So it is important for you to keep detailed laboratory notebooks that you sign and you date regularly. That'll protect you. Now, the provisional is officially patent pending now. So you have protection, but again, I can't stress this enough. It gives you 1 year of protection within the US. So we also, for this patent, we submitted what's called a PCT application, a patent cooperative treaty application. Now, I want you to think of this as an international patent, because this gives you the option for protection for up to 140 countries. The option for protection in up to 140 countries. And it gives you protection now, instead of for 12 months, it'll give you protection for 30 months before you have to file the regular patent, the non-provisional patent. So it resembles the provisional patent in that it isn't evaluated. You don't make any claims, but this patent is published. The patent office will publish this. So it's going to be out there. But you have 30 months of protection. And it is now, it has patent pending status, tells you have protection. And you can even skip this. You don't have to do this. It's just that, you know, these are pretty expensive. There's another word that you should be aware of, agent. The agent is your patent lawyers. They are the point of contact between myself and the patent office. They draft the applications. And when they draft your applications, they will borrow heavily from that disclosure document that I prepared, which is why I spent a lot of time on that disclosure document. Okay, so here we are. We have used that time. We used that time to run more experiments. I ran another 10 experiments. So now we're going into the non-provisional patent, the regular patent, the real patent. And because I've done more experiments, I'm feeling bulletproof. Now, non-provisional differs from provisional in 3 ways. First, it will be evaluated. It will be published. And third, it contains claims. Claims are the beating heart of your application, and they're difficult to write, which is why you don't write them, your lawyer writes them. Now, we made 26 claims for our feeding system. These are just the first 12. Making claims is not a do-it-yourself project. Good patent lawyers make claims as broad as possible. For example, it's not just for mosquitoes, it's for all blood-feeding insects. It's not just for our R510 diet, it's for all sorts of different permutations of that diet. Finally, we reach the second evaluation. This is the critical one because it's by the patent officer's examiner. The examiner holds the power of life and death over your application. Now, I've given you the #1 reason for rejection. Here's the #2 one: sloppy preparation, especially unclear writing. Look, realize the examiner's office is piled with applications, and it's easier for them to reject your application than trying to figure out what you really meant because the writing is vague or muddled. Also, the more claims you make, the more likely that the patent will be rejected. So making 26, you see, public health workers concerned about mosquito-borne diseases must trap adult female mosquitoes and test them to see are they carrying dengue or Zika or some other disease. So the way they do that is they set up a pan and they have a grass or leaf infusion, some vegetation inside that pan, and that attracts female mosquitoes that need to lay eggs. And it captures them in the trap. So there are 3 main components to this. You have the attractant, you have a pan to hold the attractant, and you have the trap itself, which has a battery, a motor, a fan that will suck up and capture female mosquitoes. Our idea is very different. It's a collapsible, stackable, disposable, and very inexpensive trap that's made out of just plastic coated paper. There's no battery, There's no motor. There's no fan. Here's how it works. Mosquitoes are attracted to the infusion water that is in the bottom of this bag because they need to lay eggs. And they pass through a one-way filter to reach that water, and then they are captured on sticky paper. So in addition to the trap itself, which is self-explanatory, a key innovation is the attractant, which is sealed within this infusion bag or pouch. It's almost identical to a tea bag. So what we did with that tea bag is we developed a very novel slow release infusion that increases not only attraction to the formulation, but also the duration of attraction, especially for the key mosquito Aedes aegypti, which transmits so many diseases. Now, we made 16 claims in the non-provisional patent application. And those 16 claims, of course, are the core of the application. And the patent examiner evaluated our application and he or she rejected it. Don't panic. They're almost always rejected initially. 88% of all applications receive what's called a non-final rejection. I'm dealing with one on a patent right now. The examiner's job, you see, was to challenge the 16 claims that we made. My job is to work with my patent lawyer to build counter arguments so the examiner will reconsider our application. Now, here are the claims that the patent lawyer, that the examiner, I should say, rejected. For example, here, claims 3 through 16, the examiner here is saying, look, you've got two inventions here. You got a trap and you have an infusion bag. You need to submit 2 applications. So our counter argument was that one strong patent is better than 2 weak ones, and that the 2 technologies were codependent. And fortunately, the examiner accepted those arguments. Here, he's rejecting these claims because they're written vaguely. Remember I said what the number 2 reason for rejection is? Vague writing. So those had to be rewritten. The other rejections were much more serious because they're claimed on, they're saying that there's prior art, that our work isn't novel enough, that it overlaps with earlier patents. But we had counter arguments. For example, with Lang, we simply pointed out that Lang in detail is how their traps differed from ours. Theirs is on bed bugs. They don't have an infusion. It's 2-dimensional, where ours is 3-dimensional, et cetera, et cetera. Here, claim 6. Claim 6 was rejected because the claim was stated, again, unclearly. We simply didn't write it clearly enough. So we rewrote it, made it more precise. You know, this is what's important. Never blame the examiner. Clarity is your responsibility, my responsibility. Now, you rarely get all your claims. And so we threw these out, claims 2, 8, and 9, because I didn't feel they were defensible. So we withdrew all 3. But in the end, we got 13 of our 16 claims accepted, and our non-provisional patent, which was filed in 2016, and it was protected as patent pending, was published 6 months later. And after addressing the examiner's concern, giving us 13 of 16, a patent was approved 3.5 years after the provisional patent was filed, and more than 5 years after we had the idea and started the research. Now, some of mine have gone 6 years after submission. So if you're congenitally impatient, then patents are probably not for you. Here's another idea. Let's start with need again. Here we have an island off the coast of Florida that produces huge numbers of mosquito larvae. Once a week, the local mosquito control unit goes over that island and sprays it once a week. Here's the problem. First of all, helicopters are very expensive. It costs $1,000 an hour to run one of these. Second of all, they are spraying the entire 100% of that island, but less than 5% of that island is producing any mosquitoes at all. So there's a need to do this that's less expensive and particularly that's more precise. Here's another example. This is a very densely populated city in New Jersey. It has major mosquito problems. Here's New York City is right over here, and this is the Hudson River here. So very urban environment. Now, oops. Okay, these are 7 marshy areas where the mosquito larvae are found. These areas are too small. They're too congested with power lines and buildings and highways for using conventional aircraft to spray a chemical insecticide. The need then is to develop mosquito larvicides here and deliver them with great precision. So we believe that drones can open the door to precision mosquito control. Now, we've built many drones like this powerful heavy lift hexacopter we built ourselves, but our idea is not the drones themselves, but rather to develop applications for drones. What we're interested in is developing modules that attach to drones for mosquito control and surveillance that will permit the birth, finally, of precision mosquito control. Now, here are 3 modules that we have devised for delivering solid mosquito larvicides. So here's one we developed for delivering larvicidal granules. Here's one for dispensing larvicidal tablets. And here's one for briquettes. Each one of these modules attaches directly to a drone. It's funny, it's kicking 2 ahead instead of 1. There we go. This video shows the granule dispenser in action. It's dropping insecticidal granules into a larval mosquito habitat. Now, this was filmed from an onboard camera, and it shows a reflection of the hexacopter, but you can also see the power lines that make it impossible to come in here and use conventional aircraft. This is one of the great advantages of using drones for mosquito control, is being able to get into areas that are otherwise really not accessible. This shows the briquette dispenser during an accuracy test. And you see it's very accurate. That onboard camera is invaluable for bombing mosquito habitats. And here's the tablet dispenser at work. This is an abandoned sewage treatment plant that produces massive numbers of mosquitoes, but there's no access to the facility. And there the tablet goes down. We can treat an entire facility like this without stepping 1 foot inside this toxic waste area. There is no other way to treat these otherwise inaccessible areas like this except with drones. And here's the tablet module that we just showed you. And here look, it just snaps right onto the drone. Here you see the tablets, the insecticidal tablets that are in this tube. All of these module components are nearly all 3D printed. Without a 3D printer, we could never do this work. Now, to strengthen our invention, we ran proof of concept experiments. This is a swath with the study. This gives us hard data that establishes that our inventions work, that they're not just ideas, they work. And this encourages the university, when they see hard data, it encourages the university to file that provisional application. Hard data. Once the provisional is filed, we had 1 year in order to file the regular non-provisional patent and to submit it to the patent office. We used that year to run more experiments, to generate more data for the non-provisional submission. So again, once the provisional is submitted, your work is just beginning. That year of protection is a gift. Don't waste it. So I felt we had 3 good inventions, but the examiner felt differently. The examiner accepted the tablet and briquette modules, but he rejected the granule dispenser as insufficiently novel. But still, I was thrilled to get 2 out of 3. So a patent issued at the end of 2019. And so we went from pending to patented. Several companies have expressed interest in licensing this patent. We're talking to them now. And last year, June of last year, this work appeared in PLOS 1. So we have 2 publications. One is a published patent and one is a journal publication. So 2. It's a strong incentive to patent in my mind. One more drone module. Remember this island, sprayed every week. But what if there aren't any mosquito larvae here this week? Or what if the population of mosquitoes there are species that feed on lizards and not on humans and doesn't need to be sprayed? Well, the only way is to sample. But this is an impenetrable mangrove. There is no way to reach those larval habitats without a chainsaw. Drones, however, can reach easily even the most inaccessible of areas. So we've established a need, and our idea was to develop modules to collect larvae. So here's our collector module. It's equipped with a float, and that float allows the drone to sit right on the water. It has a pump in order to suck up water and therefore mosquito larvae and deliver them into this vial here. So here's our collector in action. It gently lands, it floats on the water, and now the pump starts up. The pump is sucking up large amounts of water and the mosquito larvae hopefully as well. It has filters, so it can collect unlimited amounts because the water, it has a filter that collects the larvae but lets the water go through. So now we know whether we're going to have mosquito larvae. Just bring it back where we can study it. Now we have a vial. Now we know we have mosquito larvae and we know what species we have. Are they species that feed on humans or not? Now we can make a decision on whether we need to spray that island or not, rather than simply going in and making a weekly application. That's what I call precision mosquito control. So this is our 4th generation prototype of our collector right here. It took us 2 years to get to this point. So we submitted a disclosure document to the university, and it was rejected. The university found a video of a drone collecting water for chemical analysis, and they regarded that, in their opinion, as prior art. And so they ruled our module was insufficiently novel. Remember, that's the #1 reason for rejection. Why am I showing this to you? This failure, because the take-home message here for you was to file early. We could have filed that disclosure after we had our 1st generation collector, but foolishly, we didn't think anybody else was working along these lines. We waited 2 years to perfect the invention. Do your perfecting in that gift year you're given after the provisional is filed. That's the lesson here. So what's a good patent idea? A good patent idea does something better, faster, cheaper, easier, more powerfully, more efficiently, more effectively. And that improvement must fill a niche. That is, it has to be something people want to buy. Is there a market for it? It has to solve a problem. We like to study problems. We're professors. But patents have to solve a clearly identifiable problem. It's not important that you think it's a problem. End users have to see it as a problem, and as a problem, it needs to be solved. And a good idea is something nobody else is doing. It has to be new. In other words, there's no prior art out there. It doesn't mean you can't tweak or modify an existing idea, do that all the time, but that tweak has to show innovation. And a good idea has to be feasible. That means it has to be doable. Look, a teleportation device checks all of these boxes, but a teleportation device isn't doable. It's not feasible. I'm asked all the time where I get my ideas. Well, ideas are the hardest part of patents. So here's the single most important thing I can share with you this evening. A decade ago, I reinvented myself by shifting my research from nematodes to mosquitoes. Radically different. So I devoted my first 3 months visiting mosquito control companies and mosquito control districts. I spent time in the field with mosquito control workers, and all of my subsequent ideas, all the ones you see here, sprang from those 3 months. So get out of your lab, have lunch with end users and with industry reps, go to their labs, go in the field with them, listen to them, learn from them. What problems do they face? Because before you can identify a problem, but in order to identify a problem, you have to identify it before you can imagine a solution to that problem. Now, it may surprise you to know that you can commercialize your technology without a patent and therefore without a license. If I've got something you want, but I don't have a patent, usually in my case, because the market's too small to capture the university's interest, the default strategy is, instead of a license, is to do a materials transfer agreement, and a fee is charged for that. The university charges that fee because they still own it. But a technology without a patent is worth much less because a company has no protection from competitors. Now, here I transferred a new strain to a company in Italy for a fee of $80,000 plus 2% of sales. This one got $50,000 and 2.5% of sales. And at the other end of the spectrum, I sold a culture media to a tiny company for $5,000, which I never saw. So did I buy a Ferrari with my share? No, but I did gain prestige, early promotion. I had the satisfaction of seeing my technologies commercialized and being used out in the public. So my lab has generated 11 biological insecticide products across 4 continents. But I'm showing you this list to illustrate the downside of not having a patent, as many of these were appropriated at no cost or penalty because I didn't have a patent. And because they just pick them up because it's not protected. Patent is there for protection. Now, let me talk to you administrators. As an administrator, how do you encourage patent technology? Is patenting important in your university? Then first thing you got to do is you got to make it easy. Time is a professor's most precious asset. You need to have a well-funded, highly efficient technology office that carries the weight. 30 years ago, Rutgers had a cheap, highly ineffective technology office, and I stopped patenting for years until they finally invested serious funding to support patent activity and to take the weight off you, to make it easy. Another thing you have to do is, of course, share the wealth. Inventors at my university receive 27% of license fees and royalties. One of my students bought a car with his share, not a Ferrari though. You should accelerate promotion. This is a big one at my university. You see, there have to be rewards other than just money. So for rapid promotion, a patent at my university counts even more than a paper in a good journal. And consequently, you can accelerate your promotion time. And that was certainly the case for me. Show you care. At my university, they send a plaque or to hang on your office wall whenever a patent issues. They're telling you that it's important to patent. They hold an annual banquet to honor those who have received patents. They publish an annual list of patents and the people that have had one in the past year. In other words, they're providing recognition, not just money, not just your share. They're also providing recognition. And in academia, that carries weight. And they can offer funding. Remember this patent? This patent started with a little seed money from my university. A Brazilian company is interested in this technology, but they want to test it first. So the university gave me a quick $10,000 so I could improve the circuit board for this invention. So we then used that money to construct a revised prototype, an improved prototype, and we just shipped it out to the Brazilians. So early seed money and late prototype money is what, well, they were critical. That money was critical from going from an idea to a product. Now, let me preface this slide by saying clearly and ambiguously that most of us are clueless about marketing and licensing. We're researchers, we're not businessmen and women. I never took a business class in my life. Inventing's fun, marketing not so much. And it requires a very different skill set. But let's run the numbers. 52% of non-provisional patents are approved, but only 2% of those result in a license. Okay, so a patent isn't the endpoint. A license is the endpoint, and it's difficult to get there. How can you improve your chances? Well, as soon as that provisional is submitted, the temporary one, you should begin to generate interest in your idea by giving talks about your technology at conferences. Target decision makers, talk to them on the hallways, have lunch with the industry representatives. Now, what's the role of the owner? Remember, the owner is the university. Their role is mostly passive. Oh, they'll put out a one-page release to companies that might have an interest. But who identifies those companies? Mostly you do. They don't know the players like you do. As an inventor, you have the most important role to play in marketing, believe it or not, because it's mostly an active role. If a company expresses interest, I give a presentation on that technology, which I did as recently as last week for my auto-dissemination patent. Maybe I ship a prototype, but the role of the inventor is really key. You can't just do a patent and think you're done. And you can do it yourself. You can license the technology yourself with a startup company. Many universities, including mine, offer business incubators that provide advisors, lab space, office space, mentors, management training as a catalyst to drive economic development. You see, the universities, they want to be perceived as engines that drive the economy. Patents and startups that create jobs, that makes the university look good. And that helps in budget time for them. And there's also an intermediate pathway I haven't discussed, and that's an option to license. You see, the kind of companies that I deal with tend to be small companies usually, and they're cautious about investing in new technologies. So this is a patent that was optioned. This holds the technology for a year for that company, so they have time to evaluate your invention without fear of a competitor licensing it out from under them. And they do pay a fee for doing this. You can't expect to bridge this idea to product gap, this academic to industry gap, without building strong relationships with your counterparts in industry. Bridges built on strong relationships have provided me with invaluable advice and resources. Overwhelmingly, my successful technology transfer activities have come from networking. It's about win-win relationships. It's about partnering. It's about people. Thank you for giving me this opportunity to talk to you halfway around the world today. Anybody there? Oh,
Thank you very much, Randy, for such a nice talk today. Albeit it was very comprehensive lecture, but we have some time to take few more questions from the participants. Now the room is open for the discussion, and whosoever want to ask a question, here they may raise the hand and ask the question directly from the Randy. Please, this room is open, and please go ahead.
first of all, can you hear me?
Yes, we can hear you, and hopefully there will be a question from the participants, because we have a.
I can always write it and send it as a message
Yes.
with chat. That would be fine too.
Yes. So Randy, I have a question that one of your patent that is you have been registered with the Coopert, Netherlands. That is based on basically nematodes, entomopathogenic nematodes, or that is something else.
I'm sorry, which one?
That you have registered with the Coopert, Netherlands. Coopert.
Oh, Coppert.
Yeah.
No, that was an example of a company that didn't do a license or a patent. That was not, I didn't have a patent for that. So that's when they commercialized by simply taking it. I didn't have a license for it. I didn't have a patent for it. That's why I showed that example. That if you don't have a patent, you don't have protection. So that's why I showed those.
Okay.
So in many cases, what you do is if you don't have a patent, but you still can get a fee for using a materials transfer agreement, so you're getting some money in, the company gets your product, a nematode in that case. But once they start selling it, they don't have any protection either, and somebody else can snap it up, and that's what happened.
Here is a question, Randy, from Dr. Alaraka. He's associate professor at the university. He's asking that how we synchronize the local patents with international patents. Do local patent carry any meaning?
I'm sorry, again, I'm having trouble hearing.
The question from Dr. Alaraka is here, that do we synchronize the local patents with international patents? Do local patent carry any meaning?
Well, your local patent, you're talking about a Pakistani patent.
Well, he want to know about the comparison between the local and the international patent.
Pakistani patent is only going to provide protection within Pakistan. If you look at the Saudis, remember that I've given a lecture to the Saudis. The Saudis don't bother too much with local patents. They go straight into a US patent, and then they do a PCT, that international patent. Because the local patent, the markets are just too tiny. Whether it's Saudi Arabia or Pakistan. So most of the outfits are trying to patent in the US. And then there's interest out, because that's a big market. And from there, then they can patent easily with a PCT in as many countries as they wish. There your video shows up again.
Yeah, it is. So there is a question that how can we improve linkage between academia and industries? That question is in the chat room.
How can you improve?
Yeah, linkage between academia.
Yeah, that is so important. That is so critical. You have to go and it's all about personal relationships. There's an old saying, sometimes it's not what you know, it's who you know. Well, I tell you, you need to know people in industry. They have to be your friends. That is absolutely critical. The people in your field, you go to a meeting and you talk to your colleagues, the other professors are giving talks, and you ignore the industry representatives. Maybe they don't have a PhD. So what? Those people are the centers of influence in their companies. Build relationships, get to know them, have lunch with them, ask them questions. When you go to a conference and they have a exhibit room, an exhibit hall where they're showing their products, go in there and talk to them. Get in there and get to know them. Don't just look at their products, talk to the people. Build personal relationships. I would have no success without that. And that has yielded not just patents and commercialization, it's yielded a lot of funding and equipment. And I got $1 million. We started one idea. We didn't get any money from the company, but they gave us almost $1 million worth of product in order to do our research.
Okay, thank you. Do you recommend that the PI should directly approach the industry? The principal investigator should directly approach the industry?
Should who approach?
Who? Principal investigator of any project.
Oh yeah, absolutely, positively. Once you have your patent pending, yeah, absolutely. That's what I'm saying. Absolutely. In other words, what I'm saying is that you don't wait until you have a patent to begin marketing your idea. Once you have patent protection, that is, once you have submitted that non-provisional patent, the provisional patent, the temporary patent, start giving talks at meetings about your invention. Start talking to people in hallways about your invention. But don't talk a word about it until you have that patent pending, because otherwise, you're dead meat.
Yes. Anyhow, I think so. There are no more questions.
Disappointing.
Yes, there is another question. This is Dr. Abdullah Tariq. He's asking that please let me know about the purpose of artificial feeding method for insect rearing. As later on you have discussed about the drone method to reduce the insects. So why we are providing artificial feeding method to insects?
Well, because there's more than one. Those are absolutely different control methods. The artificial feeding system is to support the Oxitec idea of releasing large numbers of mosquitoes for mosquito control, but you're still going to need to be able to spray for a long, long time. So though one is an emerging idea, and one is a standard idea that we've tweaked by making it more accessible using drones. Two different ideas, and both are needed for a long time.
Dr. Jam is asking that how can we know about a particular thing, whether it has been patented or not?
Oh, good question. That's really important. Very good question. Very good question. It's very important because when you're filling out your disclosure document, the university is going to want to know what's been published previously or what may infringe on what you're doing. So the first thing I do is I go into Google Patents, and you can search Google Patents with keywords. Because I'm telling you, I guarantee you that the examiner in the post office, in the patent office, is going to be using Google Patents in order to search for ideas that infringe on your idea. So that's extremely important. I should have mentioned that.
There is a last, I think so. There is a question from the Dr. Atiya that when we file US patent from Pakistan, then it is for US only. Or you have mentioned that pay a patent in 14 other countries. Can we file at the same time?
140 countries. You have the option of
She's asking
countries.
Actually, she's asking that we can submit the patent as well as in US and the rest of the countries at the same time. Yeah,
again, I do a US patent first, and then If the markets seem large enough, then we will submit a PCT, which is an international patent. And it gives us the option to give us a license in 140 more countries automatically. But you don't do all 140 because there's no point in doing 140. Some of them are not big enough. You know, I'm not going to license my drone technology in Paraguay because it's too small. The markets are too small, unless they've got a big mosquito problem. Oh, no, oh, can't hear you. Can't hear you.
Thank you very much. Thank you very much, Randy, again.
Okay, you're back.
Yes, I'm back. Thank you very much, Randy, again. And at the end, I would like to convey my sincere thanks to the administration of the university. Professor Dr. Zahir Ahmed Zahir, he is the director of the Office of Research, Innovation and Commercialization at the university, and Dr. Khurram Zia, he is also from the ORIC, for organizing this unique webinar today. Once again, thank you very much, Randy, for delivering such a nice talk, and all the participants to join us today. And hopefully that all of this discussion will be very helpful for us in the niche future ahead. Thank you again, and this session is closed today so far.
Can I just say
Randy.
one thing?
Yeah, Randy, go ahead, please.
Yes, if anyone has a question they would like to ask, please just send me an email or Skype message or whatever, and I'll be happy to address any question you might have.
Randy, can you share your email or something like that?
I believe you can. What, you know what it is? You can share it.
Okay, I will share it. If anybody want to chat with him, rather they can go directly to the Google and they can search you out your name, Randy Gagler at Rutgers. They can easily find you at the Rutgers webpage. Okay. Thank you, Randy, again, and all the participants. Thank you very much to all of you. Take care. Bye-bye.
जी डॉक्टर साहब इसे क्विट कर दें.
Yes, Nadeli, thank you very much. बहुत शुक्रिया.